my name is Doris Valencia Pico. I am here to present to you the Michaelis equation, what it means and how to work this equation. So the Michaelis equation gives us a quantifying measure of the effects of the changes of the concentration of the substrates and the overall effect on the rate reaction of the enzyme. So first we're going to start with our enzyme plus our substrate is going to give us an enzyme substrate complex. This forward reaction is labeled as K1. This reverse reaction is labeled as K minus 1. This complex is going to break apart, so it's going to give us the ES producing the enzyme plus a product. In order to make sure we validate this, we will add these two equations. So we have the ES complex and the ES complex cancel out. The E and the E cancel out, and we are left with the substrate giving us a product. Now, in order to solve this, we have to make a steady state of approximation. So that means the creation of this complex is equal to the sum of all reactions decreasing its concentration. So basically, K1, which creates ES, minus the K minus 1, which consumes ES, minus the K2 here, which consumes ES. This ES equals to 0. We write this as the instantaneous rate of change for ES equals to 0, which means that K1 times E and S minus K minus 1 times the complex minus K2 times the complex of ES will result in 0. This basically is the method for initial rates where the reaction rate only depends on the concentration of the reactants. Now we need to find the value of unbounded enzymes. So we can use the total concentration of the enzyme, which is this, ET, equals the concentration of the enzyme plus the concentration of the complex. We factor the terms, and this E is going to be equals to E total minus the ES complex. We subtract it, and this is how we get the enzyme concentration here, like the unbounded concentration of enzyme here. Now, to find out the other part of the equation, we take the instantaneous rate of the ES complex divided by dt equals to 0, which is K1 times enzyme total minus the ES complex times, S minus K negative 1 times the complex again minus K2 minus K times the ES complex here. Our goal is to solve for the concentration of ES. So we want to find out the concentration of ES. So we move all the terms with ES to one side of the equation, then factor out the ES, leaving us with ES times K1 times S plus K minus 1 plus K2, it will be equal to K1 E total times S. Then divide to leave ES by itself. So it would be ES K1 times concentration of the enzyme total times the concentration of the substrate divided by K1 concentration of substrate plus K1 times K2, and we multiply all this by the fraction therefore ES will be concentration of enzyme total times concentration of substrate divided by S plus K minus 1 plus divided by K1. The instantaneous rate of change for product P is a function of its reactants. Only one reactant per reactant basically will give us ES. Oh, sorry, my camera's moving. Therefore, in order to find the instantaneous change of rate for P, we divide the T, it will be K2 times ES. So we substitute our equation for ES, which is the Michaelis equation, to get this, to get the concentration of the product. Now velocity is the reaction rate of the enzyme, and Km is the concentration of the substrate. So we have V, the of product divided by dt will give us the constant cat, which is the same as the K2 we previously saw at the beginning of the video. They just changed the name, but it's the same thing, times the concentration of the enzyme total times the substrate divided by substrate times the constant, which is the Km. The turnover number is the maximum number of molecules of a substrate that an enzyme needs to convert to product. So basically is how much one molecule can work per second. So that would be demonstrated as velocity equals maximum of velocity times the substrate divided by the substrate plus the Km. If the concentration of the substrate was equal to Km here, we would have velocity equal to V max. Now, V max would be divided by 2 times S, which would give us half of the V max. Now, we will know that Km also gives us information about the affinity of the enzyme that it has to the substrate. So if the Km is low, we know the affinity of the enzyme is high. If the Km is high, we know that the affinity of the enzyme is low, the affinity for its substrate. So this concludes my explanation of the Michaelis-Menten equation. I hope that it's understandable, and thank you for your time.